When I first learned about the polar vortex, I imagined it as a locked door in the far north, holding back a storm. But every lock has a key, or a weakness. Think back to February 2021, when an unprecedented winter storm swept across Texas. The Lone Star State, known for its heat and vast deserts, was gripped by Arctic cold. Power grids failed, pipes burst, and millions were left scrambling to survive. What caused this? The breach of an invisible force, the polar jet stream. Today, we'll uncover the science behind this climate phenomenon, what causes these breaches, and why the polar vortex may become even more disruptive in the years ahead. So, what is the polar vortex, and how does the polar jet stream keep it in check? Let's break it down. There are actually two polar vortices, one at each of Earth's poles. Each of these vortices has two layers. The first is the tropospheric polar vortex, spinning at the lower levels of the atmosphere. And the second is the stratospheric polar vortex, which is higher up in the stratosphere. These massive cyclones spin due to Earth's rotation, with wind speeds reaching up to 240 kilometers per hour. But why do these winds exist in the first place? The answer lies in temperature differences. At the equator, sunlight is most intense, warming the air and causing it to rise. Meanwhile, at the poles, cold air sinks, creating zones of high pressure. This pressure difference causes cold air to try and rush from the poles toward the equator. But it's not a straightforward journey. Earth's rotation adds a twist. Due to the Coriolis force, cold air rushing southward doesn't travel in a straight line. It curves, creating a vortex. At the boundary between cold polar air and warmer southern air lies the polar jet stream, a fast-flowing ribbon of wind circling the globe. This jet stream acts as a wall, keeping the icy polar vortex contained. However, it's not always stable. The jet stream can weaken or meander due to disruptions, like changes in sea and land temperatures, mountain ranges, or even weather phenomena like El Niño. Sometimes, these disruptions are so severe that the jet stream breaks down. This allows the polar vortex to escape southward, bringing Arctic air to regions that are usually temperate. We call this phenomenon a sudden stratospheric warming. It often occurs in late winter, with polar temperatures rising dramatically, sometimes by as much as 50 degrees Celsius in just a few days. When this happens, the once contained Arctic winds spill southward, plunging regions like Europe and North America into deep freezes. Extreme cold brought on by a polar vortex often disrupts transportation systems. Roads become icy and dangerous, making travel treacherous. Airports shut down due to heavy snowfall and low visibility, stranding thousands of passengers. Rail services are delayed or canceled as tracks freeze and malfunction. Take the 2019 North American cold wave, for example. Chicago's O'Hare Airport canceled more than 1,800 flights in a single day due to the extreme cold and snow. Meanwhile, Amtrak had to suspend several train routes as tracks froze under the unprecedented weather conditions. The power grid is another major casualty of these events. When temperatures plummet, energy demands surge as people turn up their heating systems. At the same time, the cold can freeze natural gas lines, overload power plants, and even cause wind turbines to stop working. The 2021 Texas winter storm was a stark example of this. millions of residents faced power outages as the state's infrastructure, built for warm climates, buckled under freezing temperatures. Water pipes burst in countless homes, leading to widespread flooding and leaving many without clean drinking water. In 2014, a polar vortex event swept across the U.S. Midwest, killing off wheat, corn, and soybean crops. Fruit trees in particular were devastated, as prolonged freezing damaged their buds. The economic losses from these agricultural impacts ran into billions of dollars. Polar vortex breakdowns in the Northern Hemisphere happen about 6 times every decade. As global temperatures rise, we may see even more frequent or intense disruptions. For now, the Southern Hemisphere remains safer, with only 2 recorded polar jet stream breakdowns in history. But as we continue to study these phenomena, we're discovering how climate change might alter their behavior. The polar jet stream is more than just a current of wind. It's a bastion of protection, shielding us from the frozen fury of the polar vortex. The more we learn about it, the more we realize how interconnected and delicate our planet's systems are. It's humbling to think about the invisible forces shaping our world every day, forces that we often take for granted. Thank you for joining us on this journey to understand the polar vortex. If you enjoyed this video, don't forget to like, comment, and subscribe. Let's continue exploring the fascinating rhythms of our planet.